We looked at various criteria to describe gases and liquids, but under what conditions does a gas turn into a liquid or vice versa? A phase diagram tells us. A phase diagram tells us the temperature and pressure conditions under which a substance exists as a solid, liquid, or gas. Stop the video, figure out how to use the phase diagram, and then answer these two questions. And the answers are, as the pressure increases, boiling point increases. At 1 atmosphere of pressure, the boiling point of water is 100 degrees. This black line represents the temperature and pressure conditions under which the liquid is in equilibrium with the gas. Increase the pressure, and boiling point increases. This line represents the temperature and pressure conditions under which the solid is in equilibrium with the liquid. At 1 atmosphere of pressure, the melting point of water is 0 degrees. As the pressure increases, the melting point decreases. The phase diagram also shows that under normal temperature and pressure conditions, water exists as a liquid. Is energy absorbed or is energy released when there's a change in phase? Stop the video, give the name of each phase change, and determine whether Q is positive or negative. And the answers are... Note that freezing is the reverse of melting, so the sign of Q changes. Same thing is true for condensation and evaporation and condensation and sublimation. Also note that energy has to be supplied to break the bonds in a solid to convert it to a liquid. Conversely, when a liquid freezes to a solid, energy is released when the bonds in the solid form. I lived in the high altitude of Colorado, and as a college student, I thought I'd save money and buy dried beans. So I put the beans in boiling water. 3 days later, they still weren't cooked. So stop the video and explain why certain foods take longer to cook in high altitude than at sea level. And the answer is, at high altitudes, the atmospheric pressure is less than 1 atmosphere, so water boils at a temperature below 100 degrees. A friend suggested I buy a pressure cooker, but I was a poor college student and couldn't afford one. Stop the video and explain how a pressure cooker works. And the answer is, ice skaters, whether they're tiny figure skaters or large hockey players, glide very smoothly across the very cold ice because a layer of liquid water forms between the ice and their skate. Stop the video and use the phase diagram of water to explain how this water layer forms. And the answer is, the pressure the skate exerts on the ice is very high and lowers the melting point of ice. The ice melts and forms a layer of water between the ice and the skate. After a big snowstorm on the East Coast, the reporter said that most of the snow was removed by sublimation. Stop the video and determine whether that's true. And the answer is, ice has a vapor pressure, so some ice will sublime. But the phase diagram tells us most of the ice will melt. Have you used dry ice before? Here's a phase diagram of carbon dioxide. Stop the video, use the phase diagram, and answer these questions. And the answers are, this line is a solid gas equilibrium line. At 1 atmosphere pressure, CO2 sublimes at minus 78.5 degrees. So dry ice is cold. This line is a solid liquid equilibrium line. So at pressures above 5.11 atmospheres, CO2 melts. Above 31 degrees and 73 atmospheres, CO2 is a supercritical fluid. It's the most commonly used supercritical fluid. One use is as decaffeinated coffee, another is as dry cleaning solvent. Maybe a few of you want to be an astronaut, but you don't want your helmet to pop off. Stop the video, read this page, and answer these 3 questions. And the answers are, here's you, the astronaut. And here's your eye. Here's what happens with the bends. The nitrogen gas dissolved in your blood expands when the pressure drops. A Navy diver told me the bends are very painful. An embolism is the blockage of a blood vessel, but the gas bubble doesn't get large enough to block a blood vessel. The spit on your tongue and sweat on your body boils away because when the pressure drops, the boiling point drops. It actually does it. I put water in a flask attached to a vacuum line, turned on the vacuum, and the water boiled at room temperature. See the phase diagram of water.